So this is the second video to 2.6 over quadratic functions in the College Algebra lecture series. The Vertex formula is actually derived from completing the square method, but basically it does the work for you, so you don't have to go through that method of completing square. Now, basically what you have to do to find that vertex HK is you simply calculate minus b over 2a, and then once you figure out what that number is, you evaluate the function at it, and that gives you the k value. So the h value is minus b over 2a, and the k is what you get when you plug it back into the function. So this is one we did just a minute ago with completing the square. Let's use the vertex formula and see if we get the same answer. I bet we do. A is -3, B is 12, and C is -3. So that's the ABC. Of course, it has to be written like this form to use the vertex formula. Okay, now, so that's my A, B, and C. Now, if I do minus B, I would have minus 12 over, and then I have to do over 2a, so 2 times a is -3, so that'd be 2 times -3. Well, that's actually -12 over -6, which is just 2. So the x value, or h, is 2. Now, to get the y value, I need to take the function and evaluate it at that number 2. And that makes sense, because if I know the x value on a graph is 2, then to get the y value, I just evaluate the function at that value to get the y value. And so you could do that up here. Let's see, if we plug 2 in, you would get -3 times 2 squared plus 12 times 2. Let's just go ahead and say that's 24, and then minus 3. Well, -3 times 2 squared, that's -3 times 4, so that's -12 plus 24, and then minus 3. Well, -12 plus 24 is 12, and then 12 minus 3 would equal 9. So that's how I got the 9. So I know the vertex is 2, 9. So that's how that works. So anytime you want to find the vertex of a quadratic function, you can, do it that way, unless you're forced, somebody twists your arm and makes you do it by the completing square method. Now, what's interesting is that when you have a function like this function, is it actually has, this one actually has a maximum, and other quadratic functions will have a minimum. It really just depends on which way they open. So if you look at the graph of this function, you can see that for different x values, obviously you'll get different y values, but the maximum for this function would be the largest y value that one could get. And if you look here, the largest y value you can get is actually the y value at the vertex. So that would be the maximum of that particular function. Now, let's say the function opened down. I'm going to do a little magic here. I'm sorry, did I say down? Up. Let's say it opens up. If the function opens upward, then this value at the vertex would actually be the minimum. So this would be the minimum value if it opens upward, and it would be the maximum value if it opens downward. Now, when I say the minimum or maximum value, I'm talking about this y value. The y value is always the max or min of a function. So again, if a is greater than 0, then the parabola opens upward and it's going to have a minimum value, and it's going to be at the minimum value is going to be y equal k, and it's going to occur at x equal h. If a is less than 0, then the parabola opens downward and it has a maximum value of y equal k at x equal h. So this one I just showed you, obviously since a is negative, it's going to open downward, and we already know the vertex, since it opens downward, and we know this vertex right here, the y value is 9 right here. So since it opens downward, we know it has a maximum of 9, and it occurs when x equals 2. So really all you have to do is look for the vertex and make sure you know which way it opens, so you know whether you're going to get a maximum or a minimum. Now, this particular parabola, it opens downward as well, okay? And if you use the vertex formula here, you'd have minus b over 2a, so you'd have minus negative 12 over 2 times negative 1/3. Well, that's going to be 12 divided by negative 2/3. Well, 12 divided by negative 2/3 is actually the same as 12 times negative 3/2. And if you multiply 12 times negative 3/2, you're going to get negative 36 over 2, which is negative 18. Okay, so the x value is negative 18. Now, since it opens down, I know it has a maximum, but that's not the maximum. Negative 18 is not the maximum. To get the maximum, you have to plug negative 18 back into this function. And just trust me, I did that. I grabbed a calculator and I said, okay, what's negative 1/3 times 18 times negative 18 squared minus 12 times negative 18 plus 15? And I got 123. So basically, this is a parabola that opens down. This is the vertex. In other words, this is the very top of that parabola, and the y value is this number right here, 123. So the maximum is y equals 123, and it occurs at x equals negative 18. Okay, on these application problems, why don't you guys pause the video, read the problem, and then restart the video. I'm going to just go to the work. On this problem, we're given a function here for the amount of algae in a pool based on the number of days since the pool has been treated. Well, this is a parabola, and this parabola opens upward, and so it must have a minimum. So basically they want us to find when we'll get that minimum. So since it's a parabola that opens upward, I just need to find the vertex, so I can use the vertex formula. If I do minus b, so minus b is negative 300, so I have minus negative 300 over 2a. A is 30. So that's 300 over 60, which is 5. So 5 days is the answer. Now, I have no idea what units algae are measured in, but if you plug 5 back into this function and evaluate this function for t equal 5, you can actually find the algae that you have. So you're gonna minimize, get the minimum amount of algae after 5 days, and the actual minimum is 450. Again, pause the video here and read it, and then start it up again. Okay, so on this problem, we were given two basic functions. Revenue is xp. So if x is the number of items that you're going to sell and p is the price of the item, then your revenue, you just take the number of items times the price, and that will give you your total revenue, the amount of money you take in. But sometimes the price depends on the number of items that you sell. So here we actually have a function, a price function, that depends upon X, the number of items sold. So in order to calculate this revenue function, we actually need to replace this P with 3 minus 0.1x. So that way we get a revenue function in just terms of x. So x times 3 minus 0.1x would give me 3x minus minus 0.1x squared. Or if we turn that around, minus 0.1x squared plus 3x. And now that's a parabola. It opens down, so it has a maximum. So we can maximize our revenue. So I just do minus b, which is minus 3, over 2a, which is 2 times negative 0.1. And you can plug that in the calculator, and you'll get 15 for x. And it did not ask for the actual maximum, but if you wanted the maximum revenue, you could plug 15 back into this function and get r. Just plug 15 in and see what r is going to equal. I'm going to just buzz through this one kind of quickly. Again, you can pause the video and read it, then restart it. This function represents the height of a rocket at time t. It has two questions: when will it hit the ground, and then determine the maximum height. To find out when it hits the ground, just set it equal to 0, and then you can use the quadratic formula to solve that. And I got 8.2 seconds. Now if you want to find out the maximum height, you're going to need the vertex. So I'm going to do minus b, which is minus 128 over 2a. Negative 32 would be the 2a, and so I get minus 128 over negative 32, which is 4. So at 4 seconds, it's going to max out. And then if you want to get the maximum height, plug 4 back into this function up here and solve for the s value, and you get a maximum height of 276 feet. Okay, so you've paused this and read it now, and now let me show you the picture. I have 4 pieces of fence here that have length w, and I have 2 long pieces length l, and I have 400 feet of fence here. So 4w plus 2l has to equal 400. Now I'm going to solve for L in terms of W, and I got L is equal to minus 2W plus 200. Now what I want to do is I want to maximize the area, and the area is length times width. So since I know the length can be written in terms of W minus 2W plus 200, I'll replace length with that, and I get minus 2W plus 200 times W, and that becomes minus 2W squared plus 200W. And then this is a parabola or quadratic function that opens down, and so I can find the vertex. W would be using the minus b over 2a. I get minus 200 over negative 4, which is 50, and then so that's the width. And then for the length, I just plug the 50 into this function over here, and then I get L equals minus 100 plus 200, which is the length. So the dimensions are 50 feet by 100 feet. That would maximize the area. Now what's interesting about this is that if you make these widths shorter and these lengths longer, you could still use 400 feet, but you would have a different area. So depending on what you made these widths, the area would change even though you're using the same amount of fence. So the idea here is to get the most area possible, and by using this 400 feet of fence, and it turns out I need to do 50 by 100 for my dimensions. It turns out that an interesting thing to think about, well, just think about this right here. An interesting thing to think about is what are the dimensions of a rectangle with a fixed perimeter in order to maximize area? Well, it would have to be a square. I mean, I could show you that, I just don't have time to do it. But actually, if you took the same perimeter and made a circle out of it, you would actually get more area than you would get if you got a square. So maybe that's why soda cans are circular in shape, because you're going to get a better area and then thus get more volume in a circular soda can using the same amount of material. I'm going to work one more problem and kind of tag it on at the end of this. I'll show you how to put all this together and graph a quadratic function on the next.